Good morning, dear students. Today we are going to see some of the questions of the form which I have explained you in the previous video, and then we'll see another form in the same video. Okay, so let us start with the questions. Okay, the question says integration of cos x square dx. So as you cannot use x to the power n identity in it, so that you can write x to the power n plus 1 upon n plus 1 as of you do in the differentiation. Say for example, if you want to differentiate cos square x, so what you do, you use x to the power n formula, that is nx n minus 1, but in the integration it is not so. You have to use you have to write this cos square x in such a way that you can integrate. So we are going to use 1 plus cos 2 theta, that is 2 cos square theta. So cos square theta is 1 plus cos 2 theta upon 2. This we are going to use. So cos square x can be replaced with 1 plus cos 2x upon 2 dx. Separate it, so 1 upon 2 dx plus integration of cos 2x upon 2 dx. Now integrate 1 upon 2, so it will be 1 upon 2, take out, integration of 1 will be x plus cos 2x, integration is sin 2x upon 2, and this 2 is here, plus of c. Okay, and this is the final answer. Okay, let us see this question. Integration of sin 2x cos 3x dx. What to do in this question? So see, as we see that this is, we can use an identity of see, this is a kind of sin x and this is cos y. So we can use 2 sin x cos y, which is sin x plus y plus sin x minus y. So that is why we are multiplying 2 in the numerator and 2 in the denominator. So here we can use the identity sin 2x plus 3 plus sin 2x minus 3 dx. Now 2x plus 3 is what? 5x, and 2x minus 3x is minus of x, and we know that sin minus x is what? Minus of sin x. So that's why this plus become minus. So sin 5x minus sin x. Integration of sin 5x is minus of cos 5x and upon 5, because differentiation of 5x is 5, we differentiate in the denominator. Sin x is minus of cos x, and finally we got this as a result. Okay, let us come to this question. Sin 4x upon cos x dx. How can we do this question? So first of all, you can write this 4x as 2 into 2x upon cos x. See, there is one way, like you can use, there can be one way where you can use this sin 4x identity and you can write 3 sin x minus 4 sin cube x. And after that, what you will do, you will take common sin x, you will take common from the numerator, and then after that you don't have any like approachive step to solve that particular question. So we use some different logic. So what logic I am going to use, in place of 4x, okay, we can write 2 into 2x, and we know what is sin 2 theta, that is 2 sin theta cos theta. So 2 sin 2x cos 2x, okay, upon cos x. Now see, I need to remove this cos x. I need to just eliminate this cos x. So how we are going to eliminate it? See, again sin 2x can be written as 2 sin x cos x. Now as you can see that this we don't have the rational function now. We only have the single term. So we need to, in the rational form, just always have such type of mindset where you need to eliminate the denominator and you'll get only the numerator term. Okay, so that is why we use this logic. And after that, you know how to solve it. This 2 into 2 will be 4 and sin x cos 2x. Now you can write this 4 as 2, 1 2 take out, and 1 2 here in the bracket, and 2 sin x cos y identity I have used, and I have solved like this. Pause the video and try to understand from this one. I hope you will understand. Okay, let's understand this question. Integration of sin to the power 6x dx. Okay, how to do this one? So see how we are trying to do this question. This is the 6th power. We are writing it as sin cube x the whole square, because 3 2s are 6. and we are going to use the one identity of sine 3x. What is sine 3x? Sine 3x is 3 sin x minus 4 sine cube x. Taking 4 sine cube here and sine 3x that side, so 4 sine cube x is 3 sin x minus sine 3x. Take 4 in the denominator, so sine cube x will be 3 sin x minus sine 3x upon 4. Now let us substitute this value here. So 3 sin x minus sine 3x upon 4 whole square dx. Okay, now 4 square is 16, I'm taking out, and using a minus b the whole square identity, so it will be 9 sine square x plus sine square 3x minus 6 sine 3x sine x, sine 3x and sine x dx. Now again, as you cannot integrate this thing because they are having the squares. So again we are using one identity, that as we know 1 minus cos 2x is 2 sine square x. So what will be sine x, sine square x? Take 2 in the denominator, so 1 minus cos 2x upon 2 is sine square x. But as in you have sine of 3x also, so what I am doing, I am multiplying this angle with 3. So I need to multiply this angle with 3, so it will become cos 6x. So that is how it works. So in place of sine square x, we are writing 1 minus cos 2x upon 2 plus, in place of this we are writing 1 minus cos 6x upon 2 minus, and here see I'm writing this 6 as 3 times of 2 sine 3x 6 sine x. Now I am going to give you the hint for solving after this step. So here you multiply this 9 and just integrate, because you don't need to transform anything here. Same here also. Use the identity of 2 sin x sin y, which is cos x minus y minus cos x plus y identity. Use it, integrate wholly at once and get the answer. That's it. Okay, now let us understand the today's topic, that is two special forms we are going to see, and in this we are going to see the two theorems. Okay, and let us understand what all two theorems they are. First of all, theorem 1. Theorem 1 says that if you have a integration wherein you have fx to the power n into its derivative f dash x dx, then you can directly write the integrand as fx to the power n plus 1 upon n plus 1 plus c. This is the first theorem. What you have to understand, that if you have fx to the power n into its derivative along with it, then directly fx to the power n plus 1 upon n plus 1. Say for example, if you have 2x minus 3 whole cube into 2 dx. So how? This is your fx. What is your fx? 2x minus 3 to the power 3 into 2. How to? Fx, that means differentiation of 2x minus 3 is what? 2 dx. So directly you can write that the integration of this will be 2x minus 3 to the power 3 plus 1, that is 4 upon 4 plus c. This is the final answer. Now what is the proof behind of this one? So we are going to use the substitution method. Now what is the substitution method? Try to understand. In this we need to prove this is equal to this by substitution. So how? Let us consider, let fx is equal to t. We are considering fx is equal to t. Now differentiate both the side. So on differentiating, so f dash x will be equal to dt. F dash x is equal to dt upon x. Okay, because we are differentiating t with respect to x, so dt upon x, take dx that side. So f dash x dx is equal to dt. Alright, now let us substitute all the things. In place of this fx we can put t, so t to the power n into, in place of this fx dx, what can we put? dt, so dt. Now our integration is in respect of t. So what is the formula of t to the power n dt? It will be t to the power n plus 1 upon n plus 1 plus c. Now what you have taken t as fx, so fx to the power n plus 1 upon n plus 1 plus c. So this is what the proof is. Okay. Similarly, just see the next theorem, that is, if you want to integrate f dash x upon fx dx, then you can directly write that if you have in the numerator the derivative of the denominator, then it is equal to log of denominator or log of the fx plus c. What is the proof now? Consider fx is equal to t, as of we have considered in the previous proof. Derive both the side, find the differentiation. F dash x is equal to dt upon dx, take dx that side, so fx dx is equal to dt. So in place of this f dash x dx, it will be dt, and in place of fx t, and we know 1 upon t integration is log t plus c. Now put the value of t as fx, so log fx plus c. Now let us do some questions of it, then you will understand it more clearly. Okay, starting with this question, integration of 2x plus 4 square root of x square plus 4x plus 3 dx. This square root, can we write it as to the power half? Okay, now let us check after differentiating, are we getting this or not? So d dx of x square plus 4x plus 3, we are getting 2x plus 4. So yes, this is a form integration of fx into f dash x dx. It gives fx to the power n plus 1 upon n plus 1 plus c. So directly we are using, this is the fx, so x square plus 4x plus 3 to the power half plus 1 upon half plus 1 plus c, and this is the final answer. Okay, let's see this one. Integration of log x the whole square upon x dx. Now let us frame this in one of the theorem and solve it. So how we are understanding this? Log x the whole square into 1 upon x dx. Now differentiation of log x is 1 upon x, so this is of the form fx the whole square into f dash x dx. So what will be the final answer of it? The fx 2 plus 1 upon 2 plus 1 plus c, so which is log x the whole cube upon 3 plus c. This is the final answer. Okay, if we take this question which says that 3x plus 1 x plus log x the whole square upon x dx. So let us consider this as our main function. Take 3 out, x plus log x the whole square, x plus 1 upon x. Now here just separate the x with these two, so 1 plus 1 upon x, and this one as it is. Now if you differentiate this, just check, are you getting this or not? So differentiation of x is 1, differentiation of log x is 1 upon x. So this is of form fx to the power n f dash x dx. So directly we can write x plus log x the 2 plus 1 3 upon 2 plus 1 3. This 3 with this 3 you can cancel, and you will finally get this one. Okay, let us understand this question. See, this question has some other kind of logic which you need to understand this thing. Okay, so your question is integration of sin x upon under root of 3 plus 2 cos x dx. What will be the integration of this particular thing? So what I am doing, see, as this is the rational function, so you would be thinking that this is of kind fx upon f dash x upon fx, and directly we can write log of fx. No, this is not of this form. You know, not always this rational form will be this one. It would be other also. That means it would be of fx to the power n f dash x dx, that one. So how we are going to deal with this one? See, I have written 1 upon under root 3 plus 2x into sin x dx. Now just differentiate the denominator. That means 3 plus 2 cos x. You are getting minus of 2 sin x. Okay, so we at least got that in upside we should have minus of 2 sin x, but we only have sin x. So what we are doing, we are multiplying with minus of 2 in the numerator and minus of 2 in the denominator. So minus of 2 sin x and 2 here, and 1 minus, this denominator minus I have taken up. We can take it because this minus will become plus, and this 2 will cancel and we'll get this step. So this step I have transformed it to here. How? By just knowing by just trying to make the differentiation of this as this one. Now, one thing I just want to ask you, what is the differentiation of under root x? So if you remember the differentiation of under root x, is it 1 upon 2 root x? So whatever root x you are having, the same root x you are having here, and into the differentiation of 1, which is differentiation of x is 1, which we just ignore it. So that is what we are having the condition here, that this is already, see, just let me just explain you. What is the differentiation of under root of 3 plus 2 cos x? So your answer will be 1 upon 2 root 3 plus 2 cos x into minus of 2 sin x. Will it be this one? Okay. So if you integrate both the sides, so this is already you have here. Okay, so can we directly write, see, this integration and differentiation, they both will balance and will finally get under root of 3 plus 2 cos x. So what we are trying to do here, our fx is under root of 3 plus 2 cos x. Okay, so we directly write that this is of form fx into fx to the power 1 into f dash x dx. So directly the answer is this one. Now see, I know you would be thinking that how this much logic we will apply in the examination if such type of question. So I'm telling you again and again, see, without practice it is really impossible for you to think this much, because this is by practice and practice and practice. So you need to practice very hard. You need to touch all the logics which are there in this chapter. Then only you can do some different kind of question. Okay. The last question of the video, that is 3 tan square x plus 2 times sec square x upon tan cube x plus 2 tan x plus 5 the whole square dx. We need to integrate this thing. So let us take this as fx and differentiate it. So tan cube x differentiation will be 3 tan square x, differentiation of tan x is sec square x, plus 2 as it is, differentiation of tan x is again sec square x, plus differentiation of 5 will be 0. Now if you multiply the sec square x in the numerator, you will get 3 tan square x sec square x plus 2 sec square x dx. Now this is, you have the f dash x, you take this denominator upside, so tan cube x plus 2 tan x plus 5 to the power minus 2, and this as it is. Now this is the case of what? Integration of fx to the power n f dash x, which you can directly write fx to the power n plus 1 upon n plus 1. Minus 2 plus 1 will give you minus of 1, and this is also minus of 1. So finally you will get minus of 1 upon tan cube x plus 2 tan x plus 5 plus c. Okay, so that's it for today's video, my dear student. So you just practice it. Till that, thank you so much. Have a nice day. Bye bye.